All right, we're covering two different sections today. So get your notebooks out. Can we see it? 10.2, we're in chapter 10 now. So we just took the test on chapter 9 on quadratics. That was your last major test. Now we just have a quiz on what we're going to cover in chapter 10. Just two sections and then one section in chapter 11. And then we do some work to get you ready for your Algebra 2 year to finish the year out. We'll be doing a lot of delta math the last week or two. Okay, so section 10.2, use measures of central tendencies. And those are mean, median, and mode. We have to compute those values. So what do we know a mean is? It's an average value. How do you compute a mean? If you have data, x sub 1, x sub 2, through to x sub n, you add the data and divide by the number of data, n. This is called x bar. That's the name for the mean. And so it's the average. Add them up and divide by the number you have. And that'll be the mean. Then comes the median. The median is the middle value. Now there's two things you need to look at. If you have an odd number of data items, then there will be a middle value. If you had 5 data values, your third value is in the middle, 2 to the left, 2 to the right. So anytime you have an odd number, an n is odd, there will be a middle value. That is your median. But to compute your median, you have to take your data values and put them in numerical order from least to greatest. You can't compute a median if the numbers are not in order. So line them up from least to greatest, count how many items you have. If you have an odd number of items, there will be a middle value. That's your median. Now, if n is even, if you had an even number of items, then you take the 2 middle values and you take the average of those 2 middle values. That's your median. If we had 6 items, then the 2 middle values would be the third and the fourth. Take the third and the fourth, you get 2 to the left, 2 to the right. You take the average of the third and fourth value. That would be the median. All right? So to compute a median, you have to know if you have an odd number or an even number of data values. And then finally, the mode. The mode is simply the most frequent data attribute. You can have no mode if every item is used just once. Nothing's used more than once, you have no mode. You can have one mode, which would be the one item used the most time. Or you can have more than one mode. If something was used twice and something else was used twice, you would have 2 modes. That would be called bimodal. Or you could have 3 modes if 3 things were each used twice, and that's the greatest number. Now, if one thing was used twice and one thing was used 3 times, the mode is the one used 3 times. So it's got to be a tie to have more than one mode. Okay, so that's mean, median, and mode. All right, now let's take a set of data values. So write these down. 1,000, 1,000, 1181, 1191, 1,200, 1,268, 1,328, and 2,584. There are 1, 2, 3, 4, 5, 6, 7, 8 data values. And we're going to compute the mean, the median, and the mode. So you take those 8 values to compute the mean. X bar, you add them up. They will add up to 10,752. So you go to your calculator and enter those and add them up. And then you divide it by the fact that there were 8 values. And that turns out to be 1,344. That's the mean. That's the average value of these data values. About 1,344 is the average value. And now to compute the median, what do? There are 8 values. That's an even number. So which 2 are we going to look at?
1191 and 1,200.
So in other words, the 4th and the 5th, right? If you have 8 values, the 4th and the 5th are the 2 middle ones. So 1, 2, 3, 4 is 1191, and the 5th is 1,200. So now you take the average of those 2 numbers. So it's 1191 plus 1,200 over 2, and that's 1195.5. And that's the median. That's the middle value. So each of these is some type of measure of central tendency. You have a mean, you have a median. And then the last one is the mode. And if you look, they're all used once except 1,000. That's used twice. So the mode is 1,000. All right. Does that make sense? Do we have this? So I'm just giving you the one example here for finding a mean, a median, and a mode. That's how we do it. The other thing they talk about is dispersion, which is the measure of how scattered the data values are. There's actually 2 of them. One of them we don't do. The one we do is called the range of the value. And all that is the difference of the greatest value and the smallest value. So the range here would be 2,584 minus 1,000. So that's 1,584. It ranges over 1,584. That's the range. You just subtract the greatest and the least value. All right? Any questions on this before I go to the next board? Do we all have this down?
Yes.
Everybody got all the notes? You need any more time? Everybody's got the notes, right?
Yep.
Okay. Now we go to the next section. That was 10.2. think this is a 41. Okay, now we go to 10.4. We skip 10.3. And notice we skipped 10.1. So we went to chapter 10 and we started with 10.2. Then we go to 10.4. Okay, and then I believe we do have 10.5 yet in chapter 10. That's Friday. And we'll be meeting Friday to do that. So we'll have a Zoom meeting on Friday. All right, now 10.4, interpret stem and leaf plots. They're called stem and leaf plots. They're a way to organize the data. This is a way to organize the data so that we can compute the mean, the median, and the mode. Okay? A stem and leaf plot, the leaf is the last digit of the numbers. So if you had 2-digit numbers, the leaf would be the units digit. The stem would be all the other digits in that number. If you had a 2-digit number, then it's the tens digit. If you had a 3-digit number like 105, the leaf would be 5 and the stem would be 10. It's all the other digits. Okay? In case you have 3-digit numbers. The leaf is the last digit, the units digit. The stem are all the other digits. And we're going to line them up by stem and leaves. Okay, so next thing to do is we have 20 values here. And they're just given in any order. They're not ordered. They are not ordered. So I will say them and you can write them down. You've got 20 data values, 14, 25, 8, 8, 7, 7, 19, 37, 39, 18, 42, 23, 4, 32, 14, 21, 3, 12, 19, and 41. Those are the 20 data values. And we're going to create a stem and leaf plot. What these are the number of home runs hit by the top 20 guys with the best batting averages. That's how many home runs they hit. So that's what we're studying here, the number of home runs. So here is a stem and leaf plot of this information. You write stem on the left and leaf on the right. The stems are the tens digit. Look at all your numbers. You have 1-digit numbers. The stem would be 0 in a 1-digit number. Then you have teens. The stem is 10. You've got 20s. The stem is 2. You've got 30s. The stem is 3. And you've got 40s. The stem is 4. And that's it. You don't have anything beyond 40. So your stems are 0, 1, 2, 3, and 4. And then we write down the leaves. And you just do them from left to right to start with. So 14, you would put a 4 next to the 1. 1/4, and this is called the key. 1/4 refers to 14. 25, you go to the 2 and you put a 5. 8, that's a single digit number. That goes with 0. Then you have another 8, then you have a 7, then you have another 7. Then you have 19, a 1 and a 9, 37, a 3 and a 7, so on and so forth. And here are the rest of the values. So you would have 8, 8, 7, 7, 4, and 3 are the single digit values. 14, 19, 18, 14, 12, and 19. Those are the teen values. 25, 23, 21, 37, 39, 32, 42, and 41. Those are the 20 values that we have. That is a stem and leaf plot. Pretty straightforward. Write the stems, then connect them with the leaves. Now, the problem with this stem and leaf plot is that it's not ordered. The numbers aren't in numerical order. And if you wanted to compute a median, you need the numbers listed in numerical order. So what we do from this stem and leaf plot is create this stem and leaf plot. This is called an ordered stem and leaf plot. So your stems again are 0 to 4. Now you would take your leaves and from left to right, the smallest one would be a 3, then a 4, then 2 7s and 2 8s. 3, 4, 7, 7, 8, 8. Now it's in order. Then you take the ones and you take a look. You need a 2, a 4, an 8, and 2 9s. Here it is, a 2, a 4, an 8, and 2 9s. Then you go to the 2s, 1, 3, and 5. You go to the 3s, 2, 7, and 9. You go to the 4s, 1 and 2. So from the stem and leaf plot you put together from the data values, you now write an ordered stem and leaf plot. And this is so we can find our mean, median, and mode from the ordered stem and leaf plot. Well, the mean, it turns out it really wouldn't matter. You could do the mean with either one. You're just going to be adding the 20 numbers and dividing by 20. So you're going to take 3 plus 4 plus 7 plus 7 plus 8 plus 8 plus 12 plus 14 plus 14 plus 18 plus 19, 19, 21, 23, 25, 32, 37, 39, 41, and plus 42. You would add those up, divide by 20, and the mean turns out to be 19.65. So you might as well use your ordered stem and leaf plot for your mean. Add them up, divide by the 20 data items. Now for the median, we can't do it over here because they're not ordered. We have to use the ordered stem and leaf plot. We know there are 20 data items. That's an even number. So which ones are we looking for to get the median?
10th and the 11th one.
The 10th and the 11th. So you count them, 1, 2, 3, 4, 5, 6. Go from left to right, 7, 8, 9, 10. So the 10th number is 18. The 11th number is 19. So your 10th and 11th numbers are 18 and 19. Take the average, you get 18.5. And that's the median. Because you have these ordered, you go from left to right and count till you get your 10th one and your 11th one, and then take that average. If there were an odd number of items, there would be a median. One of the numbers would be the median. But when there's an even number, you have to find the two middle numbers. Okay, and then for the mode here, we take a look at having more than one of something. We have 2 7s, 2 8s, 2 14s, and 2 19s, and one of everything else. So the mode is 7, 8, 14, and 19. There are 4 modes in this problem. There were 4 numbers used twice, nothing used 3 times. So we have the 4 modes. Okay? Do we have that? Is everybody seeing this?
Yeah.
Give me a yes.
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 Yes, okay. So we take the data, we put it in an ordered stem and leaf plot, then you compute the mean, the median, and the mode. That's how we're using a stem and leaf plot. Okay, one last thing here to make sure we see it is called a back-to-back stem and leaf plot, SLP, stem and leaf plot. A back-to-back where you're doing 2 different sets of data. We have men and we have women here. The stems are 1, 2, and 3. The leaves for the women are to the right. The leaves for the men are to the left. This is ordered from left to right over here and from right to left over here. So you would end up with women 16, 16, 18, 18. Then down here, you'd have 25 and 26. And that would be the women. For the men, you have nothing with a 1. You have 21, 21, 23, 24, 27, and then 30 for the men. That's a back-to-back stem and leaf plot. Sometimes you want to compare 2 different sets of data. And the key, if you have a 1, 2, 5, that would be 25 and 21. 21 men and 25 women. That's what that would represent. That's called the key. So to any stem and leaf plot, you need a key.
You're already having that?
Okay? Any questions on that?
No.
So this is pretty basic material you're getting into here in this chapter. You just have to follow the rules. Take good notes and study your notes. Okay? And that's a wrap for today. The next thing we're doing on Friday is called box and whisker plot. I don't know if any of you remember those, but we do a box and whisker plot on Friday. And then after that, we have one last thing on probability and odds. And that wraps up the material for the year. And then we're going to be doing some Algebra 2 material, but it uses factoring, your Algebra 1. It involves factoring. So it's a good way to review your factoring. And we will be doing Delta math assignments for all of those. All right? Here you're doing the book. Okay. So that is a wrap. And